Properties of square roots. Every positive real number has two square roots, one positive and one negative. The square root of 0 is 0. In mathematical symbols, the square root of 0 equals 0. We use this symbol, called the radical, to denote the non-negative square root of any real number. Non-negative square root is called the principal square root. So in other words, non-negative just means positive. The number under the radical is called the radicand. So for example, in the square root of 25, 25 is the radicand. So for any real number c, such that c is greater than or equal to 0, the square root of c squared just equals c. So in other words, the square root is canceled out by the squared. They undo each other because they're opposites, they're inverses. So for example, the square root of 4 squared just equals 4. Also, the square root of 8.3 squared just equals 8.3. Let's evaluate some expressions that contain square roots. Evaluate the expression -5 times the square root of 36. The square root of 36 is simply 6. -5 times 6 is -30. The square root of 81 minus the square root of 9. The square root of 81 is 9, and the square root of 9 is 3. 9 minus 3 is 6. Notice that these two could not be combined under the same radical, so you couldn't rewrite that as the square root of 81 minus 9. That's simply not allowed. Part C, we have the square root of 64 minus 13 times 3. Be very careful with the order of operations here. Again, it's tempting to want to pull out that 64 because it is a perfect square, but that can't be done. Order of operations, you start with parentheses or grouping symbols first, and in this case, the radical acts as a grouping symbol. So we simplify the multiplication first. We have 13 times 3, which is 39, and then 64 minus 39, which is 25. The square root of 25 is just 5. Another way to think about a square root is when you see square root of 25, think what number times itself equals 25. Well, that number is 5. 5 times itself, or 5 times 5, equals 25. Evaluating the nth root. So we've discussed the square root, and we know that you can take something and square it, but you don't have to stop there. You could also take something and cube it, or raise it to the 4th power or the 5th power. So of course there's an inverse to that. There's an undoing of that. So in general, we have properties for the nth root, where n symbolizes any number or any integer that is greater than or equal to 2. We can also write the nth root of a equals b. What that means is a equals b to the nth power. So if we take the square root of 121, we know that that equals 11, because 11 times itself equals 121. Now in part B, we have the cube root of -1,000. This is the first time that we're seeing a negative sign underneath the radical. That's because up until this point we were only dealing with square roots, and square root has an even root. And you cannot take an even root of a negative number. The reason is the square root or the even root of a negative number is not considered to be a real number. However, the cube root or an odd root of a negative number is possible, because if you take -10 times itself 3 times, you do end up getting a -1,000.